Page 25, last part of Unit 4, linear equation word problems. So what we're doing right now is we're taking a scenario, okay, a story, a situation, and we're going to turn it into an equation that we can solve. And now these are different than word problems that we did before, because word problems that we did before only had one answer. And when we're talking about a linear equation, it has unlimited answers depending on what your input is. You get a different output to go with it. So when we write our equations, all of them have to have an x and a y in it, okay? Make yourself a note somewhere really noticeable. All equations need x and y. If you write me an equation and it doesn't have an x and a y in it, it's not a linear equation. I'm going to mark it wrong. Okay? And then there's going to be a second part to the word problem that says, here's what my input is in one particular situation. And so then we put the input in and we solve for the output. So we end up with an equation and also an ordered pair to go with it. All right, the first style that we're going to look at is slope-intercept. And when we talk about slope-intercept, remember that we're talking about y equals mx plus b. Y equals mx plus b. And in this particular version of a linear equation, y and x are variables. M represents our what? M is the slope, okay? Slope is how much your line changes from point to point. So it's how much your scenario changes per whatever your input is, okay? So if we're talking dollars per hour, then that dollars per hour is your slope. Slope is however much it changes each time. And then B, your y-intercept, is your starting point. So we can use slope-intercept form when you know the slope or the rate of change. Okay, so dollars per hour, dollars per pound, miles per hour, miles per minute. When you know this slope and a starting value. Or a starting point or an initial amount. Okay? There's 4 different kinds of word problems that we'll look at, so you have to be able to read it and say, what do I know? If you see cost per something, then you have a slope. So you're going to use one of your slope formulas. All right. Example number 1. It says, Evan is going to the county fair this weekend. The admission to the fair is $5, and the cost per ride is 50 cents. If his parents give him $20, write and solve a linear equation to find out how many rides he can go on. What is our story about?
How much money his parents gave him on...
What is Evan doing?
He's going to the fair.
Going to the fair. Our story is about Evan going to the fair. Okay, let's read it a second time to see what numbers we have. Evan is going to the fair this weekend. Admission to the fair is $5. And the cost per ride is 50 cents.
Oh yeah, because it's double that number.
And I'm going to stop reading right there for a minute, because then I see the word if. That's going to ask me a question. That's going to come in part 2. To write my equation, I only want the base information. Evan is going to the fair. Admission is $5, and the cost per ride is 50 cents. So here's what we have to come up with. We have to decide what x means and what y means in our equation. Okay? X is our input, y is our output. And we're talking about how much money it costs to go to the fair. So our output, every time we calculate the equation, y is going to be his total cost. How much money he has spent to get into the fair and ride some rides. X I'm going to come back to in just a minute. When I read my number part, it says admission to the fair is $5. Okay, that's how much it costs him to get through the gate. So my B value is $5. My initial cost. In order for him to show up, it's $5. And that number never changes. And then the next part says the cost per ride is 50 cents. Okay, when you see that word per, that means you're talking about slope. Okay, miles per hour, dollars per hour, cost per ride. So I'm going to say my slope is 0.50, and it says cost per ride, which means X is rides, because slope and X are always attached. Okay, now I just put it into my formula. Y equals mx plus b. Y equals 0.5x plus 5. So now we have a linear equation. We could graph this. We could come up with a table of points. We could come up with unlimited number of x, y combinations where he rides some number of rides and it costs him some amount of money. Okay, if he rode 10 rides, I do 50 cents times 10, so $5, plus that $5 entrance. So for 10 rides, it had cost him $10. Okay?
What? How
If
did you get that?
I put 10 in for x, I did the math, and it equaled $10. I could put 20 rides in here, 0.5 times 20.
I'm pretty sure it's $20.
No, $5 and $5, so that'd be 10. So now 0.5,
What?
okay,
Why wouldn't it-
0.5 times 20 rides, $10, plus $5 to get in, $15. So if he rides 20 rides, he pays $15 for his night. Let's say he rides 100 rides. 0.5 times 100 rides plus $5. That'd cost him $55.
He could ride 30, couldn't he?
Maybe. We'll find out in a minute.
That's what my question was.
Right now, I'm just explaining
What
the
rides is he
XY
riding? That's my
relationship.
question.
Okay, yeah.
What?
What rides is he
No,
riding?
please don't get off topic because this is hard. Okay? So what we have to see right now is we're ignoring $20. We're not even looking at that right now. Okay, that's not part of the question yet. We have an equation that represents any number of rides he rides and how much it's going to cost him. And we could figure out any combination that we wanted to. Okay, he might ride 5 rides and spend $7.50. He might ride 10 rides and spend $10. He might ride 20 rides and spend $15. He could ride 100 rides and it'd cost him $55.
Is there like an equation that we use?
This one right here.
So y equals x plus 5.
Mx plus b, where this is our slope that
Oh.
came from the equation and this is the starting cost.
So it's slope intercept?
Correct. Yep. So now we go to part 2. Okay? These take 2 steps. You have to ignore that $20 until you get to the end. Because all of this is graded. All of this is part of the problem. Now we go to part 2. It says if his parents gave him $20, how many rides can he ride? So now I decide, is $20 my X or my Y? Is it number of rides or is it total cost? Total cost. So that $20 represents a Y, exactly. So now I take my initial equation, but this time instead of Y, I put a 20 in there. 20 equals 0.5x plus 5. And my question is how many rides? Rides is x, so now I'm solving for x. So first I'll subtract 5 from both sides. And then I will divide both sides by 0.5. So I'm going to put 15 divided by 0.5. I'm going to move my decimal to do my long division. And I end up with 30.
If it's like a problem that we're just doing our times, do you want us to do like the math?
You have to show every single bit of it, yes. Or you will not get points for this. All right. So my answer to the question is he can ride 30 rides for $20.
That doesn't look too.
It's not too bad as long as you can get your information in the equation in the right places.
That's
Okay, let's do one more together and then I'm going to have you try one on your own. It says, while visiting Crimson Lake, Sally decided to go kayaking. The Rangers charge $8.50 per hour in addition to a $25 deposit to rent the kayak. If she rented the kayak from 11:30 to 2:30, write and solve a linear equation to find the total cost to rent the kayak. So we're going to read it again. This time we're going to ignore everything after if. Okay? I don't want to know about part 2 yet. I just want to think about part 1. I wish I could just get this to fit really well right there. Okay, part 1. While visiting Crimson Lake, Sally decided to go kayaking. What is my story about?
Sally going kayaking.
Sally going kayaking. The Rangers charge $8.50 per hour in addition to a $25 deposit to rent the kayak. And I'm going to stop reading right there. Okay, that's all the information I need for my equation. I have two numbers, $8.50 per hour and a $25 deposit. So I know I need to come up with my X and my Y. And I know that I'm talking about how much it costs Sally to go kayaking. So my Y is going to be total cost again. And I'm going to come back to my X. Now I have two numbers. I have $8.50 per hour and I have a $25 deposit. Which one of those is my slope?
The $8.50.
$8.50 because it says per. Exactly right. So I'm going to say M is $8.50 and $8.50 per hour. So I automatically fill X in at the same time.
So
Okay.
this is like, we have to show this, or is this just explain?
You have to show this.
Okay.
So then my $25 deposit, that's my B value because that's how much it costs her just to show up. And now we just make our equation. Y equals mx plus b. Y equals 8.5x plus 25. And that linear equation represents any number of hours of rental and how much it would cost. Okay, so if she rented the kayak for 1 hour, it'd be 8.5 times 1 plus 25, and that's what her bill would be. And if she rented it for 5 hours, it'd be 8.5 times 5 plus 25. That's how much her bill would be. So now, part 2 says, she rented the kayak from 11:30 a.m. to 2:30 p.m. How many hours is that? 3 hours. She rented the kayak for 3 hours. I want to know how much it cost. Is 3 hours my X or my Y?
X.
X because it's hours. So you have to read carefully that second time because it could give you either value. So we're going to say that 3 hours, which is my X value, and we want to know how much it costs. So I'm looking to solve for Y this time. Y equals 8.5 times 3 plus $25. Go ahead and solve that, please. Did you guys get 255? 25.50 plus $25. So our final answer, okay, we came up with Y equals 50.50. So it will cost her $50.50 for 3 hours. Okay, when you give your answer, you have to give me all of that information. It should have 2 numbers in it, whatever number they gave us and whatever number we got, and each one has to have a label depending on which of these that number represents. I want you to try number 3 on your own.
Wait, why did I get? I got a negative.
Did you forget to put a negative in somewhere?
No.
2 negatives.
Oh, yeah, I did.
You did it right.
Nice job.
It's really surprising. Should be.
All right, so we're using AX plus BY equals C when we're combining 2 things. It says Sam ordered 2 hamburgers and 3 hot dogs from the concession stand at the baseball game. So right away, I'm talking about 2 things, hamburgers and hot dogs, okay? His bill came to $19.05. We're gonna save that information for in a few minutes. If hamburgers cost $5.25 each, write and solve a linear equation to find the cost of each hot dog. So let's start with our X and our Y. What 2 things is he gonna buy and add together? Hamburgers and hot dogs. So he's gonna walk up to the counter. He's gonna say, I want this many hamburgers, I want this many hot dogs, and the person behind the counter is gonna go, okay, this is what your total is. Okay, so we're gonna say X is hamburgers. Y is hot dogs. And now we're ready to get into our equation. Okay, the numbers that we have, it says his bill came to $19.05. That's my total. My total's always at the end in one of these. Okay, so that's going to go in for C. It says if hamburgers cost $5.25 each, write and solve a linear equation to find the cost of each hot dog. I'm going to use that in part 2. Okay, so I have
Could you
Oh.
hot dogs as X too?
you could switch them. Here we go. Sorry, my brain got fuzzy there for a second. He's got 2 hamburgers and 3 hot dogs. So he's at the check stand. Okay? He's buying 2 of X and he's buying 3 of Y, and his total cost is $19.05. And that's my equation. It has to have an X and a Y in it. Now I'm going to go to part 2. Hamburgers are $5.25 each. Hamburgers are X. So now I'm going to write 2 times that X value plus 3y equals 1905. So I rewrote exactly my equation that I started with, but I replaced the one value that they gave me after the if. If hamburgers are this cost, then what's my total? And now I'm going to solve for y. Okay, I'm gonna multiply 2 times 525 and get 1050. And here I'm going to drop my balance. I'm going to subtract that 1050 and then I'll divide by 3. And I get y equals 2.85. What does that 2.85 represent?
How much money the hot dogs cost?
Yeah, so a hot dog costs $2.85 each.
Wait. 3 divided. Oh, I didn't use a 4.
And turn the page when you're ready. Okay, we're going to do the same thing again. Tickets at a school play cost $4 in advance or $5 at the door. Total ticket sales for an evening production were $440. I'm going to stop right there. I'm going to save what's after the if. It says if no tickets. We're going to save that for a minute. Tickets at a school play cost $4 in advance and $5 at the door. What two things might I purchase?
In advance or at the door?
Tickets in advance, tickets at the door. So that's my X and my Y.
How do you know which one is X and Y?
Either one can be X or Y as long as you pair it up with the right number. Okay, so like right now I'm going to look. Tickets at a school play cost $4 in advance. So I'm going to have 4 and then whichever variable means advanced. So I said X is advanced, so I'm going to pair my 4 with my X. But I could definitely flip those around if I wanted to. And then $5 at the door, so plus 5 and then Y for at the door. Total ticket sales were $440. That's my constant. That's what comes at the end. Okay, and now my equation is done. I could graph a line. I could pick a value for X. I could pick a value for Y. And all of those are going to represent the number of tickets of one kind or the other that I've purchased. Okay? This says, if no tickets were sold in advance, if no tickets were sold in advance, which of my variables is advance tickets?
Or X, sorry.
X, yep. And how many were sold in advance?
We don't know.
It says
Oh, none.
if
None.
none. So we're going to put a 0 in. Okay, so for our part 2, we're going to do 4 times 0 plus 5y equals 440. We're going to solve for y. I came up with 88, which means there were 88 tickets sold at the door. And 0 tickets sold in advance. That's only one possible combination of tickets, but that's how many suit this story. Okay, try number 7 on your own, please. Okay, and I have an equation and an answer up for 7. If you've got it, try 8. And if not, try again or ask me a question.